When we look at anything in the universe, no matter how near or far, we are never seeing it as it truly exists in this exact moment. Our eyes, our instruments, and even the most advanced detectors humanity could ever build are all limited by one fundamental rule of reality. The speed of light is finite. Although nothing in the universe can travel faster than light, its extraordinary speed is still not infinite, which means that every signal we receive, every image we observe, and every distant object we witness is shown to us not as it is now, but as it once was. The light that reaches us carries with it a timestamp from the moment it left its source, whether that moment was a fraction of a second ago or billions of years in the past. This unavoidable gap between emission and observation forces every observer, including us, to fill in the missing pieces of now through inference and calculation rather than direct perception. Remarkably, if an observer has not spent long periods traveling near the speed of light or experienced extreme gravitational time dilation, such as the kind found near the event horizon of a black hole, then their sense of right now aligns with ours from the perspective of cosmic time. They exist just like we do, roughly 13.8 billion years after the Big Bang, which marks the beginning of our observable universe. Time since that event is shared universally unless relativistic effects disturb it. For objects close to us, the delay between light leaving them and reaching us is so small that, for most purposes, we can ignore it. However, as we extend our vision farther into the depths of space, we are inevitably also looking further back into the past. The more distant the object, the further we are peering toward the beginning of everything. This fundamental truth of light travel leads to some fascinating consequences. For instance, if someone far from Earth were to look at our planet, they would never see us as we exist today. Instead, they would see Earth as it existed at some point in the past, depending entirely on how far away they are. The farther they are, the older the version of Earth they would witness. Even within our own solar system, this time delay, though tiny, is measurable and meaningful. Consider Voyager 1, humanity's most distant spacecraft. At present, it lies an astonishing 168.7 astronomical units from Earth, each astronomical unit being the distance between Earth and the Sun. That translates into about 14.7 billion miles, or 23.5 billion kilometers. Since its launch in 1977, Voyager 1 has been journeying outward for nearly half a century, crossing beyond the termination shock and inching every year deeper into interstellar space. It is one of only a handful of spacecraft that humanity has launched on escape trajectories, destined never to return. Unless a future mission overtakes it, Voyager 1 will remain the farthest human-made object for all time. Yet despite its great distance, the view it has of Earth is surprisingly recent. The light that reaches Voyager 1 from Earth takes only about 23 hours and 23 minutes to travel the vast gulf between them. So if an observer were riding alongside Voyager 1 and looked back toward our home planet, they would see Earth not as it is now, but as it was less than one day ago. Likewise, someone standing on the Moon sees Earth as it was just over a second earlier, while an observer on Jupiter sees Earth approximately 44 minutes in the past. From Pluto, situated on the cold and distant edge of our planetary neighborhood, Earth is visible as it was roughly 4 hours and 51 minutes earlier. These numbers reveal how small our solar system is when compared to the enormous scale of a single light year. Voyager 1, moving at tremendous speed by human standards, will require tens of thousands of years before it travels even 1 light year from home. Outside the solar system, the nearest objects to us are the stars that make up the Milky Way, and even the closest of these lies so far away that the light we see from them represents moments in history long gone. The brightest star in our night sky, Sirius, sits 8.6 light years away. That means anyone living in a planetary system around Sirius would see Earth as it existed 8.6 years ago. To a Sirian observer right now, Earth would appear frozen in late February of 2017. They would witness events that, for us, have already faded into memory. They would see Donald Trump being sworn in as President of the United States for the first time, an event that shaped political discourse across the world. They would also observe Israel announcing plans to build a new settlement in the West Bank, the first such plan in 2 decades, a decision met with extensive international criticism due to its legal and diplomatic implications. They would witness a devastating fire sweeping through Manila in the Philippines, leaving over 10,000 people without homes. At the same time, they would see Adele triumph at the Grammy Awards, winning major categories such as Record of the Year and Song of the Year, while Chance the Rapper secured the award for Best New Artist. From their vantage point, they would also see Frank-Walter Steinmeier elected as the president of Germany, and they would watch the start of the annual Iditarod sled dog race, which in that particular year was relocated to Fairbanks due to unusually low snowfall, a reminder that Earth's climate patterns were already showing worrisome signs of long-term change. Even Earth's atmosphere would tell a story to distant observers. They would detect the seasonal fluctuation of carbon dioxide levels, noting that, during winter months, the concentration occasionally dipped below 400 parts per million, a threshold it has since crossed more permanently due to continued greenhouse gas emissions. To them, Earth's radio, television, and communication signals would also reveal a great deal. Our cultural output, scientific achievements, entertainment broadcasts, and global news would all be detectable as faint transmissions washing outward into space at the speed of light. An advanced civilization around Sirius would be capable, given adequate technology, of decoding these signals, analyzing our patterns of communication, understanding the languages we speak, and piecing together a detailed picture of our world. They could determine our level of scientific progress, understand that our civilization uses electricity, radio waves, and digital communication, and even infer aspects of our politics, environmental conditions, and everyday life. If they chose to respond, their earliest possible reply would take another 6 years to reach us, meaning any two-way communication would require at least 17 years to complete a single round trip. Such communication would be slow by human standards, but still remarkably short for a cosmic dialogue compared to the distances separating us from most stars. This reality extends across the universe at every scale. When we look at stars tens or hundreds of light years away, we see centuries-old or millennia-old versions of those systems. When we observe galaxies millions of light years distant, we are witnessing their ancient past, long before any human civilization existed. The farthest galaxies ever seen are viewed as they were billions of years ago, showing us snapshots of the universe in its early stages, when stars were young, galaxies were forming, and elements heavier than hydrogen and helium were still scarce. Every image we capture with telescopes, from the closest asteroid to the deepest galaxy cluster, is a glimpse into a time machine built into the fabric of space itself. Light carries information, but it also carries history. When we admire the night sky, we are surrounded not by a portrait of the universe as it exists at this instant, but by a grand archive of ancient light, each point a relic of a different epoch. Everything we see is delayed by some amount of time, and the greater the distance, the deeper the look into the past. This means that the universe we observe is a layered tapestry of moments, spread across billions of years. In every direction, the cosmos reveals its story not as a present-day reality, but as a vast collection of memories still arriving at our eyes.